meet you in such a big group to today's webinar about CANopen bootloader. Seems to be an interesting subject. So my name is Reiner Zitzmann. I hold the degree of electrical engineering from the University Erlangen-Nuremberg. In the meantime, the general manager of CANopen GmbH, which is a 100% daughter company of the CANopen Association. And our main task is to provide the services intended by the association to be provided to the members, to provide them to the members in the best way. So if you're from a CANopen members company, my team and myself are appreciating to assist you, serving you in case you have any demands with regard to CANopen. In addition, I'm acting as a trainer in CANopen seminars, provide technical consultancy services, and I'm also representing CANopen on conferences, trade shows, and so on. Furthermore, I represent CANopen in the international standardization. So CANopen is very open to submit CAN-based specifications prepared at CANopen to the international standardization body. So we are doing this in a very broad range. And myself, I'm taking part in the working groups related to the usage of CANopen for public charging of light electric vehicles, of the application field where CANopen is used as a consist network in rail vehicles, or where it is standardized how certain devices interact that are mounted at a superstructure on a truck, for example, at the refuse collecting vehicles. And there we have several levels, the international level, German level, European level, and I'm acting there for these subjects as expert from CANopen. Just as I said, CANopen is the owner of the CANopen GmbH. So CANopen is an international users and manufacturers group that develops and supports CANopen and other CAN-based high-layer protocols. The non-profit group was founded in 1992 to provide CAN-based technical product and marketing information. The association fosters the image of the CAN technology and provides a path to future network technologies. So what does this mean? On the one hand, we are trying to arise awareness for the CAN technology. So this means we write technical articles, submit them to newspapers, to magazines. We are going to fairs, to trade shows to indicate that CAN is and will also in the future be a good mean for linking together sensors, actuators, host controllers in embedded applications and embedded networks. And furthermore, if you have any challenges in CAN-based projects, you can come to CANopen, because since 1992 we have established a huge social network of CAN experts, and maybe we have already gathered enough knowledge about CAN and can help you directly, or at least we can rely on our huge social network and can ask our members, can you assist with regard to this request and give some advice how to solve this or that challenge. Yeah, therefore, I like to invite you, making use of the availability of such an international users and manufacturers group, taking this into account when you work with CAN-based networks, that you're not alone, but there's somebody that is very willing to assist you so that your CAN-based solution works. Furthermore, brief look to the history. Founded in 1992, CANopen. As I've said, we're trying to keep the awareness with regard to CAN. What is nowadays more and more difficult, because CAN goes deeper and deeper into the application, so it gets somehow invisible. But we see also today, with regard to the amount of attendees, many people are still interested in CAN-based networking, and therefore it is good to have such an association as CANopen, showing that CAN is still a relevant candidate for embedded communication and that CAN is still a vivid technology. So you see here in the upper part of this slide that CAN is doing something to highlight CAN, to raise the awareness of CAN, that we are writing specifications to assist people also in developing independently from each other and to establish somehow a multi-vendor network when solutions from different companies meet in the very same network. But on the lower end of this slide, you see that there's a lot of development ongoing in CAN. So we see here in 2012, so there was the presentation of CAN-FD, the CAN with flexible data rate. Maybe some of you haven't heard yet about this CAN-FD. So this was an improved way these days to communicate in CAN-based networks. So to have a higher data throughput, to have a higher communication speed, to have a lengthened data field. These were some advantages provided with CAN-FD presented in 2012, and I'd say on the road in the cars since 2018 to 2020. But when this CAN-FD was presented, then some people at CAN Automation and the member space, they thought, well, maybe we have also now to update the higher layer protocols such as CANopen, J9039 or others to make use of the improved capabilities provided by CAN-FD. And therefore, we updated, for example, the CANopen specification. A first release was in 2017, just by end of this year, we released the latest version of a CANopen FD. So an improved higher layer protocol, taking the basis of CANopen and enhancing, modifying it a little bit only there where it's needed to allow CANopen protocol stacks to make use of the CAN-FD data link layer attributes. And while we were doing so, there were also coming some people from Volkswagen and other CiA members that were indicating, well, this CAN-FD is a nice approach, but we need for some applications even more functionality, more data throughput. And then the development of CAN-XL was started. An extra long CAN data link layer frame was developed, and you see by end of 2021, the first specifications were released, the data link layer specification, the physical layer specification, describing CAN-XL, a CAN frame that is capable to carry up to 2000 bytes in one CAN frame. So this is, for example, needed in some backbone applications, and to not put too much delay on such a cable, then you can communicate, depending, of course, on your environmental conditions and your topology and setup, with up to 20 Mbit in the data phase, such a frame. So you see, CAN is still a vivid technology. A lot of development is still ongoing to keep the CAN-based data link layer meeting the requirements of today's and futures, as I said, embedded networking requirements. And here, somewhere in the mid of the listing of all these activities, with something that is relevant for today, we see here end of October in 2021, there was an inaugural meeting of a task force generic bootloader. So it has in principle in mind the basic generic classic CANopen, but it should also have the openness to CANopen FD and other CAN-based higher layer protocols if it is possible. But we saw also there a lot of people said, well, this bootloader topic could be of interest, and therefore we joined this group, assist these activities, and within 2 years we made a lot of progress, which we will discuss or which I will present in certain terms today. Yeah, so briefly that you see that CAN automation is, or the CAN is still a vivid technology. You see also here with regard to the amount of members, so we are still having an increased number of CAN automation members. So at the moment we have 736 members, so it's a constant growth of members compared to the last year, the beginning of the last years. So therefore, we see CAN has still a good relevance. And briefly to CAN automation, for those of you who are not that familiar with CAN automation, CAN automation is generating CAN automation specifications with the objective to make CAN-based devices, solutions, or to give them a certain degree of plug-and-play capability. And then when we have written these specifications with strong support of our members, we are going to make some marketing for these specifications. So we say why it is reasonable in this or that market to provide a CAN-based solution, what are the advantages, what are the possibilities there. And furthermore, we try to introduce these specifications to the engineers. So we give some seminars, technical lectures, and so on to assist them so that they know how to apply these specifications to assess the possibilities of a certain solution. And as I said, CAN automation provides a neutral ground where companies can meet according to antitrust laws so that they can negotiate how should a device behave at its CAN interface for providing interoperability to other solutions, CAN-based solutions that have been developed by other market competitors. Just that you get an idea, what are these members doing in our groups? We have on the one hand marketing groups, technical-oriented groups. So the marketing groups, they organize some marketing activities. At the moment, our activities are very strong with regard to CANXL. We are currently in charge of developing a CANXL website for decision makers, introducing the key factors of CANXL and why it is reasonable to support CANXL in certain solutions. What are future applications field for CANXL? We organize or coordinate at which trade shows we should present CANXL or which conferences, provide some materials that introduce the benefits and the reasons for CANXL. And we did this also in the past for other markets. So I think we will also in this year start some new marketing activities with regards to CANopen, CANopen FD, and maybe also we restart certain other marketing groups, but this will depend. And if you say I'm in a certain market active, for any CAN automation member, it's possible to contact CAN automation and to say we want to initiate some activities in this or that application field. For the technical groups, you see here, we have a lot of activities coordinated by our technical committee. You see here the broad range, starting with the lower layers over the higher layer protocols, CANopen, J9039, CANopen FD. We are dealing with certain device implementations. How should devices provide data at its communication interface for a certain device class? This we manage in certain device profiles or application profiles if we have entire applications in mind. We're dealing with redundancy. How can I increase the availability of an application? So I had just this week some talks how to restart these activities because high availability is an important issue in maritime applications, in satellites, in train control systems. So this has a certain relevance, and therefore we will restart these activities. And just today we had some discussions with regard to safety, security anyway, is a very hot topic. So also here for that we have a working group. So if you are interested, please contact CAN Automation Office for joining. And today, as I've said, we are talking about the bootloader, which was directly handled in a task force by the technical committee. And finally, to the introduction of CAN automation, so that you know who is the organizer of this webinar, I like to emphasize that CAN automation is also supporting the information interchange with regard to CAN-based technology. So we are organizing from time to time an international CAN conference where experts can meet and can exchange their latest experiences in CAN-based networking. The next edition will take place in Baden-Baden, the 18th CAN conference. And the past CAN conferences, there you find at CAN Automation website, a lot of valuable technical articles. You will find at YouTube all the talks. And as I've said, if you like to take part, the 14th and 15th of May this year, there we will have the International CAN conference. So I'd like to invite you, get a participant there, or if you are interested in exhibiting, there's also the possibility for becoming tabletop exhibitor. Yeah, therefore, once again, warm welcome from my side to today's webinar. And the topic of today is the CANopen bootloader. Therefore, let's start with CANopen. What is CANopen? Why is CANopen somehow interesting? So CANopen had been pre-developed in a European research project under the leadership of Bosch in 1993 and was finalized then more or less in 1994. The result of this project was the CAN-based application layer-based communication profile, the version 1.0. And from these days, more or less, the success of CANopen started. CANopen nowadays is used in a lot of applications, and of course not in this very early version, but in a version 4.0 hosted at CAN Automation in the document 301. And the last changes at CANopen were then done in December 2007. And this is the last version, let's say the 4.2, which has just some optional features in addition to that 4.0 version, which is equivalent to the European standard 5325-4. So since a long time, CANopen is stable, no changes, so you can rely on your developments and can rely on the CANopen functions, as you know, from the early days of CANopen, from now 20 years ago. So nevertheless, in the meantime, we see CANopen has improved with regard to CANFD. We have there since November last year a version 1.1, the CiA 1301 version 1.1, and where we have introduced some learnings that were available in the early days of CANFD applications, and therefore we could improve our first version with regard to these experiences. Yeah, nevertheless, CANopen, as a very well established technology, has still some points where we have to react on current demand. So one of the topics is the firmware update via the CAN interface. And therefore, we had also, as I've said, in 2021, to establish a working group with regard to the bootloader. So, but these were not the first ideas with regard to a bootloader. And therefore, it's, I think, worthwhile to analyze where do I find something with regard to bootloader. So CANopen is not a monolithic document, but CANopen is a so-called profile family or family of specifications. We have the basic CANopen specification 301, and here you find the device architecture, how a device stores or where a device stores its data, how is this data communicated by means of CANopen services at the end of the day in form of CAN telegrams. So how does a device behave at the CAN interface, and how can I read data, write data to this CANopen device or from this CANopen. But there exists, in addition to this very simple functionality that is in CiA 301, a lot of amendments, additions to this basic functionality. And one is in the document CiA 302 in the -3. There we find the CANopen program download. And when there came up first devices that had the requirement to fulfill the firmware update via the CAN interface, then some manufacturers thought, oh, this would be the ideal document then to use this for bootloader applications. And so over the years, we extended this document for firmware update over the bus. Just for giving you an idea with regard to CANopen, this is the CANopen device architecture. We have our CANopen object dictionary, we have our CANopen services, some for data transport, some for network management. And this we have in mind when we want to do the firmware update via the bus in a CANopen device. Then we can rely on this device architecture. A little bit more technical view is now provided by the CANopen FD specification, where we say we have a field device. This field device hosts a CAN FD device where we have our bit rates and bit timing settings. And then on that, we have our CANopen device. And there, CANopen FD provides, in addition to a node ID, a network ID, but this is here the only difference between CANopen and CANopen FD. And we have here a more detailed or more precise look on what is supported. We have here our NMT server. So in former days, we would have said the NMT slave. Now, because of wording, we say now it's the NMT server. And here we host our NMT state, whether we are either pre-operational, operational, or stopped state. We have to think about our classification. Is this device a server or a manager device, or old language or master application? So has this device the ability to control other devices, or is it controlled by a master application? What about error handling and the indication of errors? Is this supported? Which device functionality is supported? All this is now here sorted and listed in a clean way in the CANopen FD device specification. And this in implicit way was already provided in CANopen, but here in CANopen FD we have explicitly written it. And I have chosen this slide here for today because for all of these features we have to think about when we are talking about the bootloader during a bootloader mode. What is there supported in a CANopen bootloader? What makes a CANopen FD or CANopen device a CANopen device? Which functions are mandatory, which are nice to have, which depend on certain circumstances under which I like to fulfill a bootloader mechanism. Therefore, it's wise to update a little bit everybody so that you're clear, okay, what we are talking about. Furthermore, I just like to remind you on the NMT state machine. So for most of you, I think this is a very clear thing that we initialize, we set our application parameters in a CANopen device, we communicate our communication parameters, and then when our bit timing is applied, our bit rate is now set, when our node ID and network ID settings are done, and all the parameters are initialized, then my device can do the transition from the initialization state to the communicating state, so typically to the pre-operational state. And also here for CANopen, this was everything clear for CANopen FD. We are a little bit more precise now. This I've taken from the CANopen FD specification, where we see, okay, we take here care about some details with regard to node ID, network ID setting, and we clarify here something else. When starts a manager, respectively master functionality, or we would find here also some IDs where some further functionalities would start. So this may be important also for a bootloader process, that we know, okay, when do we expect some manager master functionalities. And finally, I like to remind you that we have a database in CANopen, the object dictionary. So it's a list of references where in my CANopen device do I find certain data. And I don't want to go into details too much. So I think there exist some very important ranges, area 6000, some standardized parameters, standardized by CiA, device and application profiles. So with regard to the application of the device, some manufacturer-specific data, and the index range 1000, which provides communication-related data. So I always say, when I want to change or modify the behavior of my device at the communication interface, at the CAN interface, I have to go to the index range 1000, and there I will find the parameter, to change, to modify the behavior of my CANopen device in the intended way. So also for bootloader functionality, the CANopen specification provides some interesting parameters, and we can have later on a look on them. First of all, I like to remind you on the Object 1000. The Object 1000 is one of the few mandatory objects in the CANopen environment. And here in this object, I get the information which device profiles are supported. So I have a 32-bit number. And in this 32-bit number, I can see, is there an I/O module functionality supported, drive functionality supported, or a hydraulic drive or a sensor functionality. I see this by reading the device profile number. And for CANopen FD, this is more or less the same. So here in CANopen FD, I have also my profile number. But you see a little change here. There's a certain specific function field. So why is there a specific function field? If I go into details of the specification, then I see, there is just the 0 specified for the moment. But this has a reason. So when the CANopen FD specification was written, and this discussion was about 2016, 2018, somewhere in this time frame, we had already in mind that there had been issues out there around the bootloader handling that we want to indicate, is there currently a bootloader ongoing or bootloader process? Is the device in bootloader mode? And then we want to highlight this. So we had first indications, okay, we have to differentiate at a device whether the device is currently in a bootloader mode, yes or no. And we took this requirement already when we developed the CANopen FD specification, but for further details, as we cannot solve everything at the same time, we said, okay, we have to postpone the detailed discussion on that, but we reserve here already the possibility to indicate this device is currently in a bootloader mode, and we did this extension in a way that it would also work in a classic CANopen. Yeah, and then for today's topic, maybe it's just worthwhile to clarify a little bit what we are talking about, and therefore it makes sense to have a look to the document 302-3, and there in its latest version, we have a definition of the CANopen bootloader. And here we find the information. A CANopen bootloader is software in a CANopen device that is able to receive the data of a program download and start the program. A bootloader is called active if there's no program software running that provides CANopen functionality. It is not defined in the specification which objects are the mandatory part of a bootloader and how a bootloader can be deleted by a CANopen manager, detected by a CANopen manager or a tool. This may be specified in a device profile whenever a CANopen device comprises such a bootloader and the bootloader is active. Object 1000 shall return the value of the bootloader device profile. If one or more programs are started that provide the functionality of a CANopen device, the value of Object 1000 shall return the corresponding profile. So we see we have some basic definition. What is the bootloader? We have now the option to update the firmware of the device, the option for the program download. But we see also in the lower part of this statement that we are messing around somehow with the Object 1000, that there starts already some degree of freedom for the handling. And we will see this when we analyze how this bootloader was then lived and filled with life in certain CiA device profiles. So let's start. What is now specified with regard to the CANopen bootloader in CiA 302-3? So in general, we have everything what we need. So there's a flowchart defined in CiA 302 where we see, okay, when we start the bootloader from the perspective of a tool or a CANopen manager, then we analyze in the tool, do we have an expected program version, a program that number or version number that we expect in the device itself? We can do a read access to a certain parameter in the object dictionary of the device, and we can evaluate the red response and can see is the expected program software ID identical to that is in the device, and if no, then we want to fulfill our bootloader process. And we can then double check, is this process allowed? Is it allowed to reset the device? And if everything works, we can stop the program, clear the program, and download the new program. And then we wait during the flashing. And then when the flashing was successful, the device is again responsive, then we can double check, do we now see the right software ID? And then if everything is fine, we can start the program. We can then double check whether it started correctly, whether the device shows the right version number, the right origin. And if everything is correct, we can start the device and put it into service. So from the basic function, everything looks fine and looks very clear. So we see here we have also in CANopen our objects in the object dictionary. We see here we have the object 1F50 where we manage our programs. So I have written here from the perspective of a server, of a device. So within the device, we can manage here our project. So this is, for example, the objective where we download our programs to. And if we have then there one or several programs, we want to manage them, control them, to start them, to stop them, for example. And nevertheless, we need also some information in the manager device or the tool device. As we have seen at the manager device, we want to host the version number of the expected program software. And on the other hand, we want to double check in the device whether it's the right version currently running, or we want to detect whether the version is outdated. And furthermore, we have here for managers also the possibility to host already the program, that if we have, for example, the requirement that the firmware at a device is somehow erroneous, we can do just a new flashing process and we have directly in the manager device the program available. So you see here, furthermore, with regard to the device itself, we have the flash status indication, we have the program software indication. So everything from a minimum base of view is available so that we can do our CANopen bootloader. So let's see how this bootloader handling was ongoing. And here, for example, in the specification 417, it's based on CiA 302-3. And there we did some additional specifications that we said, okay, we want to use this in the lift environment, but there, if a device is in bootloader mode, it shall have the node ID 126. We demand some mandatory objects. So in addition to those that are mandatory in CANopen, we demand the heartbeat, which shall be transmitted also when the device is in a so-called bootloader mode. So this means we distinguish here between the bootloader mode and the application mode. So in the CiA 302, it was just in a verbal form. Now here it's some two separated modes where we differentiate between bootloader mode, application mode. Nevertheless, we are very clear in both modes, the device shall be a fully CANopen device. And we see here, there were also some first thoughts with regard to password protection for allowing the switch from the bootloader mode, from the application mode to the bootloader mode. Also, the file, the software itself, shall have some identification values so that a device that gets the software as a new firmware has the ability to double check, is this really a correct firmware? Is this firmware really from an authorized body? So I have here some kind of security inserted. Let's have a look. How is it in another CiA specification, the CiA specification 443? It's also based on CiA 302-3. But we see here, we don't have a fixed node ID value, 126, but we see, okay, there we need the layer setting services, LSS. It's a further service in CANopen that allows dynamic distribution and assignment of node ID via the bus from the perspective of a host controller or a master application. And we have also the ability to switch via these services the bitrate. So we see this is a little bit different as it is in the aforementioned elevator control application. And we see here, with regard to some security thoughts, which are also considered here, we have a program erase lock. So not everybody is allowed to erase software, but only authorized people, and therefore they have to identify themselves via such writing a key to this object. So it's a little bit a different solution as it had been in 4.17. Similar, but different. So we see, why do we have here a big difference? We see here the mode switching. When the device enters after power on the NMT pre-operational state, it is in bootloader mode. So after power on, you are directly in the bootloader mode. You are not in the application mode. And therefore, it makes no sense to have this program lock from their perspective when you are in application mode, because you're directly automatically enter in bootloader mode and have there the access. And therefore, for allowing access control, they inserted this new object. And a third example is the profile for energy management. And here we see it's also based on CiA 302-3, but here we have an indication. We have once again a fixed node ID for 126 for indicating that a device is in the bootloader mode. So once again, the restriction, I can only update one device after the other, not several at the same time. We indicate that a device is in bootloader mode in the object 1000. So we distinguish also, as all the others, between bootloader mode and application mode. We are using a similar object as in the sub-C here for allowing a switch to bootloader mode. So via the object dictionary, we have here the possibility to trigger the switch to a bootloader mode. This is needed, for example, because you don't have NMT service control available, but you have to ask for the switch via an STO request. And furthermore, for the mode switching, it's not just sufficient for having this write access to this object, but the device has also to be in a certain application state. So we have also a dependency to the local state, device application state of the device application. So summing up, we see that we have already in these three application fields bootloader mechanisms based on 302-3, but we have several flavors of this bootloader mode. So the switching between application mode and bootloader mode differs. So the good thing is all of them differentiate between these modes, but some switch between these modes based on the FSA states, application states, or on some password writing or unlocking to the object dictionary. They behave different with regard to the node ID. Will the device, while it's transitioning from application mode to bootloader mode and vice versa, keep the node ID, change the node ID, or demand a new node ID value? Is it expecting to get a new node ID via LSS? Heartbeat services are sometimes provided, sometimes more or less forbidden or not recommended. So there are also in some applications security issues considered, like how can I identify a software if I'm in the position of the device that gets the software with kind of identification, hash values, and how can I, by a simple read access, identify that the device is in a bootloader mode. There, the aforementioned object 1000 is of interest. And here also a strong guideline was missing. So this makes it very difficult for tool providers because tool providers would say, hey, here I have a tool, or I support this in a CANopen manager master application. And with this procedure, I can update the firmware of the most overwhelming percentage of the devices in the field. And therefore, there was a need to say, let's harmonize here everything a little bit, give a strong direction. How should a CANopen bootloader work? And there was here a question in the chat, therefore I can just take it for the moment. How is the process for sensor profiles like CiA404, CiA46? Is each profile its own process? So I don't know all the specifications by brain, but the second part of this question is already the answer. First of all the profiles have their own process, more or less. And therefore, I have chosen 3. I could maybe have found more if I did a more deeper analysis. But this was exactly one of the motivations to say, let's start a working group that harmonizes all this, and that all the other working groups trying to search for recommended handling method for bootloader can rely on this harmonized method. And therefore, we have the scope of this group. We see here the task force generic bootloader provides recommendations and specifications on how to treat typically challenges in case of updating the firmware of CAN-based devices via the CAN interface. It is not the aim to make existing bootloader implementations invalid. It is intended to limit the amount of future bootloader implementation. It's exactly addressing the question. So what did we have in mind? Which kind of use cases? So we see this here. We had several use cases in mind. The one is the very simple one that we say, okay, you are in a laboratory maybe, and you want to update the device, the firmware of a single device. You have a CANopen expert that is using the tools. You have full access. You are in a secure environment, and you have all the means that you need to update the device. So this is a very simple use case. The node ID can be fixed. All the environmental conditions are under your control in this one-to-one session. A very simple use case. A little bit more tricky is the next one that you say during end-of-line production you want to use this firmware update, and you have typically a one-to-N session, and there the node ID handling is more tricky. So if you would work with a single node ID indicating the bootloader mode, as node IDs have to be unique in a CANopen network, you could only update one device after the other. And therefore, you have to think about the node ID distribution. Maybe this should be done dynamically from the host controller. The tool needs therefore to have some management functionality. And you have to think about certain security measures. So maybe you're directly in your factory, so you can say, well, my environment is secure. Nevertheless, you could think about some security issues to avoid an unintended misuse. Then what gets a little bit more challenging is that you are somewhere in the field that a CANopen expert has to update now to do some diagnostics and update in a running system or in a system that has been put to service somewhere, maybe on a construction site or wherever. And in this setup, you want to update the already installed device, and the CANopen expert accompanies there the firmware download in an application that had already been put into service in a one-to-one, one-to-N session. Now it depends. Can we work here with a predefined node ID for the device in bootloader mode, or do we have dynamic node ID allocation? In some applications, the same node ID is therefore required in application mode and bootloader mode, Also, this you have to think about. Also, keep in mind the limitations with regard to the performance. And nevertheless, your tool needs to have manager services, NMT services, and you need some certain degree of security to identify the user as an authorized person. And finally, we see the most challenging use case, update over the air. There's nobody around the application. And also in this setup, where it is not guaranteed that you have CANopen manager services, you want to update your device or your application. And all these requirements we have had take into account when we did our work in the task force generic bootloader. And what was the motivation? Is there a question in the chat for this new bootloader mechanism? As I've already said, it's not quite new. We have already in various applications a flavor of this CiA 301, the 3 specification bootloader, which was introduced somewhere in the year, I don't know exactly, 2002 or something like that. So it's available for a long time, but it left so much degree of freedom because some use cases like the update over the air were just not practically available at these days. So therefore, we started with our activities in the task force generic bootloader. There, what were the subjects that we have discussed there? The definition of the transition between the bootloader mode and the application mode. How can we take it? When is it allowed? In which FSA states, application states? What about security mechanisms? Is there a password writing, unlocking necessary? We want to have a statement with regard to node ID handling and bitrate handling. Maybe we need to extend the object dictionary by some further entries that provide some additional functionality. We want to have an indication whether a device is currently in the bootloader mode. Therefore, we need to update the object 1000, which I've already shown to you. We have always the trade-off that you say within a bootloader mode, you want only to support a minimum of functionality. On the other hand, sometimes there comes the desire, well, I want to have this function and that function. And then you have to do some assessment. What would be really helpful, what is really needed, and what would be nice to have. And therefore, we need to have a categorization on which services we can rely, which are nice to have, or which are even not recommended for being supported in a bootloader mode. We also need some statements maybe to the handling of multiple programs or the consideration of configuration sets. We want also to have the consideration of the capability of updating only shares of the firmware. Furthermore, we want to have some statement with regard to the update of the bootloader software itself, the rollback functionality. If there an application goes wrong, maybe we want to fall back to certain settings. Authentication mechanisms for bootloader activation, program configuration control. And we had also the discussion how generic should this work item be. This connects somehow to the question that we had already in the chat, that we have to say, yeah, the initial point was the CANopen bootloader. Then we open it with regard to the CANopen FD bootloader. And yes, we can be more generic, maybe that it's also useful for J9039 and others, and we could also double check what about UDS. But the starting point had been CANopen, and there was, I have to admit, a strong focus on CANopen. Nevertheless, in a second step, we could also double check whether that, what we have already, whether we can also bring in line with others. And what we see also here, that we have also double checked, can we or have we do some statements with regard to the view of the client, how to run such a bootloader process from the client perspective. Yeah, all of these questions have already been discussed, and the results were added to the document 710, which I'm going to introduce now in the next slides. But not all of these features are really added. So sometimes there was also the decision, well, this would be too restrictive. We cannot agree because the use cases are too different there. We cannot give a common statement. Therefore, if you're interested in all the answers, then you should have a look in the meeting protocols of the Task Force Generic Bootloader. There you will find all the discussed items more in detail. And all the protocols are available in our website in the members area where we arrange the groups. The results where we agreed on a common workflow were now added to a document 710. For you as a CANopen user, 700 number range in CiA document sounds a little bit strange. What is document 700? We have there a common specification for CANopen and CANopen FD, and we say, okay, CANopen and CANopen FD provide a toolbox, and in CiA 710 we specify how to use the toolbox. And then we have seen that we need some additional tools, so we did already some amendments, but when we finalize 710 and the document is released, we need also to update the document CiA 1301, which is currently under development, and we will do an amendment for CiA 302 so that all the functionality described in 710 is available. What is defined in the document 710? We see this here. We introduce the bootloader mode and the application mode. So when you switch on a device, it is first of all entering the state bootloader initializing. There it is double checked whether some programs are marked as Autostart. So we have introduced an Autostart where you can say some programs shall be started. If there's nothing, then you will automatically enter the bootloader mode. But if you have there highlighted a program that shall be started, then this program will be verified. Is this correct? Will be checked. And then if everything is fine, the program will be started and your device will start in the application mode. Otherwise, as I've said, if there's no program, then your device starts in the bootloader mode. So this is, let's say, a kind of prologue to the well-known CANopen state machine that you know from the CiA 301 or from the CiA 1301, that you enter then, you're initializing and you're communicating states. And when you're in communicating, you have there in parallel, if you are either in bootloader mode or in application mode, the communication state machine, and here in parallel also the state machine for the bootloader mode, respectively for the application mode. And as we see here, if we are in the application mode, if I want to modify the running firmware, I have to authorize myself, identify myself to the device, say, well, I'm an authorized user, therefore I write my security key and can go then to the application mode, allow bootloader start, and initiate the bootloader start. And then after a certain waiting time, I will enter via the paths over the state machine, the bootloader mode, and I can identify that I can to the device that I'm allowed to update the firmware, to download firmware, so I can then do the firmware download and start a certain application after a while. So this very basically the principles here. So how should the entire transition between bootloader mode, application mode work? What is available as basic device functionality, clarifying that a CANopen device exists also in bootloader mode as well as in application mode. All this is then done by the specifications here, 710, with a lot of details. We have also discussed the node ID, network ID, and bitrate handling. Depending on the use cases, we couldn't agree on a common recommendation for the node ID handling. This really depends on the use case, whether it's more attractive having a fixed node ID or whether it is very reasonable to forget the node ID during state transition. or mode transition, and to readjust the new node IDs via LSS. With regard to bitrate, we said it's very critical if you change the bitrate during this mode transition from application mode to bootloader mode. The node ID should, the bitrate should remain. And if you need changing the bitrate, then you should do this via layer setting services, for example, then as soon as you are in the intended mode. When we talk about diagnostics, also here we increased the functionality. So a device has now the ability to inform you that there is something ongoing with regard to the flash, maybe that the flash was not prepared, cleared, that the flash is secured, that is therefore just read-only, or can give you just some notes or warnings. So this we improved in this document CiA 710. So that is maybe more comfortable to do this firmware update, because you get information why does something fail, or why does something not work in the intended way, and you can directly correct your behavior according to the information that you get here from the device. But this means also that you have to have the emergency service available. This brings us to the question, which services are available in a bootloader mode? Also here we try to clarify in the document 710, and we said the emergency services, they are highly appreciated to inform the user, the tool, why is something not ongoing in the intended way. So they are very helpful, but nevertheless, they are just optional. Because in some applications, I have nobody around who can start some countermeasures. It would just take some processing power, providing in bootloader mode this diagnostic functionality. And therefore, I say, well, I don't need it in this use case. So emergency services, very helpful, but just optional. PDO, time, sync. We have considered that they are not that useful during the bootloader operation. It would just be consume processing power. Therefore, we said it's not recommended. Of course, for getting access via the means of CANopen to a device, you need the SDO server functionality. So the first SDO server is mandatory. There were some pros and cons supporting block transfer or segmented transfer. So you have the choice, you have to support it. And further SDO functionality is just not recommended. And in the related way, we have the same for the USDO. The heartbeat producer is mandatory, but the consumer is not recommended. What does it mean, heartbeat producer is mandatory? You have to support the functionality. Nevertheless, this gives you the degree of freedom to switch it off in your use case if you don't need it. But nevertheless, you have to rely on the functionality heartbeat producer would be available if you need it. Yes, of course, the settings can differ between the application mode and the bootloader mode for the heartbeat. As I've said, in some applications, you don't want to have the device transmitting, so you can set the heartbeat then to the value 0, then it's switched off. But the functionality itself has to be available. Boot up is mandatory anyway. Network management is, as a consumer perspective, mandatory. You have to receive the NMT commands. On the other hand, the producer is not recommended. So the NMT manager functionality, if there is one available, it should be switched off during the bootloader. And LSS optional. If it's needed, if you support it, then at least the basic functions, switch state global, switch state selective, and configure node ID shall be available. And furthermore, we have also discussed the rollback function. So there's always the possibility that a newly downloaded program is defective. So for this purpose, we have now the option that we can mark one program as a so-called default program, and that cannot be deleted. And if you do the bootloading process, the firmware update, and for whatever reasons this fails, and you have not an intermediate device, but if the software is not running, at the end of the day, you can fall back to the settings as they had been marked in this default program. So also this functionality we have introduced. So you see here a summarization of the objects relevant for bootloader mode. Not all of them we touched or we introduced now in these activities. You see all that are not touched are kept in white. So we have here some yellow ones. There we did some modifications. This is, for example, with regard to the program control and the flash status. So for example, for the program control, we added here the functionality that we said we can differentiate between a program and a configuration that belongs to a program. So maybe you have for a program several configurations, and now you can enable, disable configurations. You can at least host configurations here. And furthermore, we have in the object 1F57, we have here added some further flash status identification. We can see are there errors, which one, and we can here also indicate the rollback program. And we have some objects that are new that need to be added also to documents like 1302 and 302-3. There we say we want to indicate the Autostat, the application security access, mode switch delay, bootloader, and so on. So I have now on the next slide summarized these new objects and indicate here briefly the purpose. So we see here the Autostat, which application program is started after power on. This is given here or adjustable here if you like to have it. You have also the possibility to highlight priorities. So if you have several programs that shall be started, you can say first start this program, and this, and that. We have introduced the application security access. Here, more or less a domain is provided. So according to your security rules, you can generate and write a certain key so that the device is enabled to recognize, is this an authorized user? Then we have learned that switching between application mode and bootloader mode may also require a write access to the object dictionary where I say, and now transit to the bootloader mode. Or I ask or initiate a transition to the bootloader mode. And maybe you don't have NMT commands available because you are also acting as a simple CANopen device with your tool, and then you want to do this request via the object dictionary, and that the object dictionary entry does not vary from device to device. We have now one predefined object. It's the object 1F5B, which provides this functionality. We have another object 1F5C. 1F5C, sorry, I mixed it up. Furthermore, there was a wish that if I don't have a trained technician enabled to translate certain checksums into version strings and so on, we have also the possibility to indicate the application version as a string, so to increase human readability if it is needed, depending who is using this tool. And furthermore, we have the possibility here to provide further identity information on the supported application program, also for increasing the human readability. Finally, we want to have more detailed information about the flash. What about timeouts while reading, writing, or erasing flash memory, for example, for assessing how long does this firmware update in process take? Is it still a reasonable time, or got my device somehow stuck and it does not make sense waiting anymore? So also here we added some new functionality. That will be also listed then or added then to CiA 302 or 1302, but we can use it already as we have specified in the document CiA 710. Yeah, finally, we added all these things to achieve our objective to reach a harmonized procedure for firmware update. So it is assumed that there is a CANopen device running an outdated application program that requires an update. The given steps, as listed here in this table, they are required to update the application program. So this description here of sequences is given from the point of view of a generic bootloader client. So what are these harmonized steps? First of all, get access to the protected data elements, or do the security access. Then switch from application mode to bootloader mode, erase the memory, the corresponding application program, download the new program, verify the application program. Then, if it's available, enable the auto start, and then start the program and leave the bootloader mode. So these steps, one after the other, you fulfill in this harmonized simple procedure. And as I've said, we want also to consider the client view, that we have a harmonized recommend procedure. And therefore, we see here, we have sequence diagrams. And this is just one example. Download the application software. They see, okay, step by step, what I need to do. Okay, I read the program software identification from the given object. I see, okay, it's prepared. There's nothing in. The flash status says, okay, no valid program available. So this means we can start. We download the program. We write the flash. We can nevertheless pull the flash status and see whether the update is still in progress. And finally, we can read the version number and can see whether everything is correct. So in this way, all these steps that we have seen on the previous slides are depicted by sequence diagrams. So this makes also the handling and the implementation of a client very simple, or more simpler than had been in the past, where you have always to figure out, okay, what to consider, how to deal one, when shall be which step after which one. So therefore, I think with this document, we can assist the users of CANopen and the manufacturers of tools for CANopen bootloader mechanisms on the one hand, and the other one, the device designers that want to say, okay, in which way will my device be updated enormously? So summing up, we have now a document CiA 710 generic CANopen bootloader, and it's going to provide a harmonized handling for firmware update. CiA 710 uses the means that have already been specified in CiA 302-3 and take the learnings from further application fields into account. Thus, the base is prepared to allow generic CANopen tools using one typical handling procedure for simple firmware updates. So this tool client view is covered by sequence diagrams. So as I've said and as I've shown, it's very understandable for all the people that have not been part of this working group. You can very easily see, okay, what is meant and how should I implement, how should I behave. CiA 710 is still a work draft, yes, but has passed the final working in the task force. So we have now to do some formal things. We have to submit it to the technical committee of Canon Automation, and then we can publish it. And all the CiA members have nevertheless already access to the document CiA 710, which is as final work draft available at Canon Automation's website. You see here when will we have some further seminars and technology days. So you can also follow us with a CiA in Action Technology online, where we discuss a lot of current topics in CAN-based networking. We will have in Asia 2 technology days on site, but details are not scheduled yet. And we will have further webinars. The next one will be on security and on CAN XL. You will find always the latest activities on our website, which is a treasure trove for information, where we have the next seminars, webinars, and so on, where you can meet us. The publications you see, we have now also a new service like the current community news, which comes every 3 weeks and informs you on latest news on the CAN community and the CAN market. Social media, the fairs where we are, and then yeah. So thank you for the moment. Are there any questions from your side? So for the questions, you can use the chat either, or you can use the audio function, unmute your micro, and then you can ask. There comes a question. Is CiA supporting with open source development here? So we just write specifications. We don't support specific developments, but if you like to provide, you can also implement according to this specification. So as I've said, we don't host by our own any kind of implementations. This is then done by our members or the open source community. And there are incoming further questions. Will there be a generic programming tool similar to the conformance test tool? So not from CAN automation side, but as I've said, our members have already tools considering the bootloader. And this initiative was, for example, driven by companies that are, among others, providing CANopen bootloaders, because they say, if I want to update devices, I don't want to double check which or how does this bootloader work in this device and in that device. Therefore, we want to narrow the flavor. We don't want that every CiA working group is specifying a new flavor. We don't want that every manufacturer is specifying a new flavor. And therefore, when you start thinking about bootloader, stay to this harmonized procedure, and that make, therefore, the tool manufacturer as well as the device users happy. I'm on the last slide, and I will ask you for the last time, if there are any questions, please indicate. Otherwise, if these questions come later on, then just write us an email, give us a call, and we try to assist you. Okay, so far I don't see any further questions. I don't see anybody writing. Well, I hope it was interesting and you received a good update what we are doing with regard to CANopen bootloader. Yeah, and I'm wishing you much success with your CAN-based projects. Have a nice evening for those that are based in Europe, for all the others, a nice day. And yeah, see you next time on one of the next CiA events. Thank you very much for joining. Goodbye.